So today we're going to talk about horizontal and vertical translations. We talked briefly about translations the other day, and so we're going to start with vertical translations. So this is what happens when something is added or subtracted to a parent function. So the first thing we're going to do is graph the parent function, which is y equals x squared for this particular example. Now this graph is going to be vertically translated 3 units up. And why is that? Well, that's because of that right there. And in the vertex format of the quadratic equation, we have y equals a times x minus h squared plus k. A, we remember, tells us the direction of opening and whether or not there's a stretch or compression. We're not dealing with those today. But remember what k tells us. K tells us if it moves up or down. So that's what we're going to focus on in this particular question. So now we have x squared plus 3. So we haven't really talked about mapping, but we're going to start. So this k value in this particular equation, it calls, we refer to it as mapping the y value. All right, so what happens is, if you'll notice, my x values aren't really going to change, but my y values are. So look what happens to my vertex. My y value of my vertex is going to stay at 0. Sorry, x value of my vertex, I will get it right eventually, stays at 0. The y value maps up 3 units. So then go to my next point and the next point, which here is at 1, 1. The x value stays the same. The y value is going to map up 3 units, so now it's going to be at 1 and 4. And we're going to do the same thing with the other side. And so as you can see, we're going to just get the same curve. Now this one's going to run off the curve. So the 1, 2, it'll be around up here. And so there is our translated graph. So this red graph is y equals x squared plus 3. Oh, sorry, not y, we have it as f of x. So f of x is the parent graph, y equals x squared, all translated vertically up 3 units. Well, let's look at this graph. We now have a graph. Our parent graph is y equals x, and we're looking to translate that. So now we have f of x is equal to x minus 2. Well, if we don't even look at the fancy-dancy stuff of all this mapping notation, think about it. If I had an equation of a line that was y equals x minus 2, what do you know about it? Well, we know that the y-intercept is minus 2 and that the slope is 1. And so, oh wait, let's look. All these points are mapped identically down 2. So our new function is f of x equals x minus 2. So it has been translated down 2 units. So this is one of the new graphs that you looked at today, was that y equals the square root of x. And now we're going to start. I apologize, I have not been putting domain and range on the other ones. Let's start doing that now. So we'll start adding a domain and range to these things. So here's our parent graph of y equals the square root of x. And I've got the domain and range up here, where the domain is x is in the real family such that x has to be greater than or equal to 0, and y is also in the real family such that y also has to be greater than or equal to 0. We need that restriction in order for this to be a function. So now we're going to say, we're all right. Now I'm going to have function g of x is equal to the square root of x plus 4. Well, it's pretty easy to do. All I'm going to have to do is map all of these up 4. So that's 4, 2, so that's going to become 4, 6. And this one is 9 and 3, which is going to become, might run off the table, I'm not sure. 9 and 3 is good. No, it's not. 9 and 3 is going to become 9 and 7. So this is now our g of x is equal to the square root of x plus 4. Whoops, sorry about that. So again, note that when all I have is this value, so I'm just adding a number to the function, all it's doing is mapping the function up or down by that factor. So this really is now going to be an exercise in practice for you of how to graph some of these parent functions. Now here I'd like to take note of what happens to the domain and range. Notice that nothing happens to my domain because my x values are remaining the same. This figure here maps the y values. So the y values now, instead of the y having to be greater than or equal to 0, my range now has to be y's in the real family such that y is greater than or equal to 4 because we mapped it up 4. So here we have the parent graph, y equals 1 over x. And remember, we have two asymptotes, which means we have to have two restrictions, one restriction on the domain, one restriction on the range, in which neither can be equal to 0. And now we're going to look at h of x as it's moving the parent graph down 2 units because we've got this minus 2 here. So let's graph that in a different color. And all these units are going to map down 2. Or all these, sorry, not all these units. All of these points are going to map down 2. And so what I have here, x11 is going to map down to 1, negative 1. And so now we have the new graph mapped down 2 units. So it has been vertically translated down by 2 units. And so now what we have, if you can see this, is we don't have any difference on our x. So we don't have any difference on what our restrictions are on our domain. So our domain is still going to be, so as you can see, we still are not touching the y-axis. So we've got d is in the real family such that x is not equal to 0. But look what happened to our range. Our range, remember, mapped down 2 units. So we have a new asymptote. So our new asymptote is now going to be y is in the real family such that y is now not equal to negative 2. Because notice, just let me get a highlighter here, not an eraser, a highlighter. See how negative 2, that line right there, is our new asymptote. This was our old asymptote, and now we have our new asymptote because we mapped that graph down 2 units. So don't be afraid of this graph. This is when we're going to do 2 to the exponent x, and I want you to note that when I have an x minus 4 in the exponent like this, there is an inherent bracket around that. What we have been doing up to this point is moving the graph vertically, so that would have been represented by y equals 2 to the exponent x minus 4. That would map the graph down 4 units. But because the minus 4 is up here in the exponent, it actually means that this is now going to be a horizontal translation. And so we're going to translate the entire graph to the right 4 units. So there's your new graph. See how every point has been mapped to the right 4 units, and how our y values have not changed. So when we do a translation that is horizontal, our domain isn't going to change, but our range could. So let's look at our domain of our parent function and note that there is no restriction on what x can be. X can be any value from negative infinity to positive infinity. So what about the range? Well, remember that our x-axis here is an asymptote, which means that it will never equal 0. So therefore, y must always be greater than 0. So that is our range restriction. Y is greater than 0. So now when we've translated that graph to the right 4 places, what has that done to our domain? Well, I hope you guessed absolutely nothing. Our domain is still any real number, and our range is still y is any real number such that y is greater than 0. So now let's look at the square root function. We'll just graph the parent function y equals the square root of x. And again, anything under the square root sign is an inherent bracket. And so therefore, this is now translating the entire graph to the left too, because our y value will not change. Our x value is the only thing that is changing. So you may have noticed, again, my range does not change. I still have a restriction that y is not able to be less than 0. But this time there is a restriction on my domain, and so therefore my domain will change. So we'll put the parent graph domain, which x has to be greater than or equal to 0, in black. And now you can see my range has shifted 2 units to the left, just like my whole graph, which now means that my domain of my translated graph is going to be x is any real number such that x is greater than or equal to -2. So our summary for this is that f of x plus c moves the graph f of x vertically up or down. And f of x minus d moves the graph of f of x horizontally left or right. So the video is getting a little long, so combining horizontal and vertical translations, all I'm now going to do is just describe the translations and leave the graphing up to you. So here we have g of x is equal to the absolute value of x plus 3 plus 1, and it's a translation of y equals the absolute value of x. And so if we see this, remember, this is going to translate the graph left 3, and this is going to translate the graph up 1. So I'm just going to write those translations down. Those are the translations. And similarly here we have y equals the square root of x plus 3 all minus 2 as a translation of y equals the square root of x. And so this is going to be horizontally translated left 3 units and vertically translated down 2 units. So you go ahead and graph those two, and I'm just going to really quickly show them at the very end graphed. Don't forget to do your restrictions on your domain and range. So there is your parent graph and your translated graph. And remember, because now we have done both a vertical and a horizontal translation, our domain and our range are both affected. So you go ahead, graph all these functions. Don't forget your restrictions. Don't forget to restrict your domain and range depending on what your mapping has happened, whether or not your domain has new restrictions or your range has new restrictions. Have fun with this, and we'll take it up later.